Hi everyone. In this video, we're going to check out some techniques for solving trigonometric equations. Let's get started. In this first example, we're going to look at this simple equation. The algebra involved in this one is really straightforward. What we want to think about is solving for the trigonometric function in the equation. So in this particular case, we want to get this equation to say, cosine equals a number. In part B, you'll want to look at ways to find tangent equals a number. But we'll get there in just a second. So now that we have cosine x equals 0, what we need to do is identify all angles whose cosine is 0. All angles whose cosine is 0. So how can we do that? Well, we're going to start with the unit circle. And what we want to remember is on the unit circle, the coordinates are cosine sine. So what we can think of is the angles on the unit circle whose x coordinates are 0 are the angles whose cosine is 0, right? So as of right now, we've got x equals pi over 2 and 3 pi over 2. But is that all? And that is the question. So there's a couple ways of finding all angles whose cosine is 0. And the first of which is going to be to think about coterminal angles. So let's think about the angle pi over 2. And let's think about the angle 3 pi over 2. And so we can remember that the cosine of pi over 2 is 0. Easy peasy. We can remember that the cosine of 3 pi over 2 is 0. That's satisfying the original equation here. But also, let's remember back from chapter 4 that coterminal angles have the same sines and cosines. So in other words, that, whatever this is, this would be pi over 2 plus 2 pi, which in this particular case would be, 5 pi over 2? Well, in theory, the cosine of 5 pi over 2 is also 0. Not even in theory, in reality. And if we want to check that, if we want to verify it, of course, we can bring up our Desmos. We can bring up our graphing calculator. We can go bring up our scientific calculator. Make sure we're in radians, and we can remember that the cosine of pi over 2 is 0. And we can remember that the cosine of 5 pi over 2 is also 0. Remember, anytime you add a revolution, you're maintaining that sine and cosine. The same argument can be made for 3 pi over 2. Adding 3 pi over 2 plus 2 pi would be 7 pi over 2, right? So the cosine of 3 pi over 2, remember we're just verifying, we're checking our solution, so is 0. And the cosine of 7 pi over 2, right, is also 0. So basically what's happening is, remember, any angle that ends in either the red spot or the blue spot has a cosine of 0. That's the idea of that big word, coterminal. Right? So all coterminal angles have the same sines, cosines, tangents, etc. So anytime you see coterminal, or anytime you see the phrase get all of the solutions, you are going to need to consider your coterminal angles. Okay, so now that we've kind of talked about that, let's look at it a little more practically speaking. So we're here, and we're at these two angles. Okay, so in practicality, remember, we need to consider all the coterminal angles. Right? So what we can think of is, so these red and blue angles, fortunately, we can just go pi to get from red to blue, and we can go pi to get from blue to red. So here's how we're going to frame this. We can say it's pi over 2 plus pi. It's pi over 2 plus 2 pi. It's pi over 2 plus 3 pi. All of these things, pi over 2 plus 4 pi, pi over 2 plus 5 pi. Hopefully you're seeing the idea. Any one of these will get you a new solution. So when we're talking about all solutions, we want to think is x is pi over 2 plus 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, any whole number pi, where n is an integer. Right? And so that is our full answer to all solutions. Pi over 2 plus n pi, where n is any integer, and that combination of things will get you all of the solutions to this equation. In the next example, we will look at a couple more. In the next video, rather, we'll look at a couple more examples of finding all solutions to a trigonometric equation. And in class, we're going to look at how to do this graphically.